Welcome to qnawire.
Problem 11.21. So, if you have two anti-parallel forces acting at different points on an object, this is in this case we have forces that are 8 newtons in magnitude, and the first one is 3 meters away from this end of the rod. So, what we want to do first is figure out this separation we want in order to produce a torque of 6.4 newton meters about A. And we want to answer the question of whether this torque is clockwise or counterclockwise. So this is just the magnitude of the torque. And then we want to repeat this to produce a 6.4 newton meter torque from these forces about point B. So let's just write down the torques. So the first torque from the first force is going to be 8 newtons times our 3 meters. This is 24 newton meters. We're saying that counterclockwise is the positive direction of rotation, as usual. The torque from the second force is going to be negative 8 newtons, because this is directed downwards. And then this is going to be multiplied by our 3 meters plus L. So we want the sum of the torques to be, in this case, it's going to be negative 6.4 newton meters, because the force producing a negative torque is further away and they're equal in magnitude, so this produces a greater torque, and so its tendency will be to spin, if we allowed it to, in the negative rotational direction. So we just add up the torques. We have 24 newton meters minus distribute this. Well, no. Distribute it. 24 newton meters from our 8 newtons times 3 meters minus 8 newtons times L. And so this is just negative 8 newtons times L. So L is going to be 6.4 newton meters divided by 8 newtons. The negative signs have canceled. You can also just sort of intuitively do this, that you see that L has to be positive, so you just, you can sort of not worry about being too formal about this, because it's sort of obvious what it's supposed to do. But if that's not clear to you that it should be positive, then you can always be careful and think about it a little bit harder, and that's fine. Anyway, this gives us that L needs to be 0.8 meters. And we could already tell from the beginning that this is clockwise, because the force that produces a clockwise torque is further away, and so it produces more torque given the same amount of force. Oh. I made a slight mistake in drawing the setup of the problem. For part C, we want to know the separation in order to get a 6.4 Newton meter torque if it's about the point where F2 is applied. So just redrawing this real quick. We don't have to worry about F2 at all because its moment arm is 0. So tau 2 is equal to 0. Tau 1 is equal to negative because this is now producing a clockwise rotation about this point. And so we want our 8 newtons times L to give us 6.4 Newton meters. And you can see this ends up being exactly the same as in part A. Where L is going to be 80 centimeters. And again, this is going to be clockwise, which we could already tell just from the setup of the problem. It's even easier here because if we're finding what the rotation about this point would be, this is clearly just going to be driving it clockwise, which we said is our negative direction.